Okay, this is the last page of our group review quiz. So here's our differential equation, x to the fourth times y minus 2. Okay, so it says do a slope field on the 12 points. Okay, so 0, 0 means we have 0 to the fourth times 0 minus 2, which is 0. Okay, so anytime x is 0, anytime x is 0, we're going to have a 0 slope. So up the y-axis, we have a 0 slope. Okay, also, anywhere that y is 2. So look at the point 1, comma 2. That's 1 to the fourth times 2 minus 2, which is 0. So anywhere y is 2, we're also going to have a 0 slope. So how about these other points? What about 1, 0? That's 1 to the fourth power times 0 minus 2. 1 to the fourth is 1, so this is a negative 2 slope. Negative 2 slope at 1, comma 0. So just like that. Okay, how about 1, comma 1? That's 1 to the fourth over 1 minus 2, which I believe is just negative 1. So a little bit flatter at 1, 1. Okay, how about 1, comma 3? That's 1 to the fourth times 3 minus 2. Well, that's a positive 1 slope. 3 minus 2 is 1. Okay, now let's look at the negative ones. Negative 1, comma 0 is negative 1 to the fourth times 0 minus 2. Well, negative 1 to the fourth is positive 1. So this has a slope of minus 2. Okay, negative 1, 1. Once again, that's negative 1 to the fourth, which is positive 1, times 1 minus 2, which is a negative 1 slope. So flatter. And then we're up to negative 1, comma 3. Negative 1 to the fourth. 3 minus 2. 3 minus 2 is 1. So this once again has a positive 1 slope. Okay, so those are your slope fields for your x to the fourth times y minus 2. While the slope field is drawn at 12, it is defined at every. Describe all points in the xy plane for which the slopes are negative. Okay, so hopefully you know that raising anything to the fourth power, this is always going to be an even number. Not even. This is always going to be a positive value. Raising something to the fourth power is a positive value. Anytime we raise something to an even power, we get positive numbers. So the negatives are going to come from this part. So when will y minus 2 be negative? Right? Because it's going to be a positive times a negative is a negative. So our values are going to be negative anytime y is less than 2. So any y value less than 2, anything below this horizontal asymptote is going to have a negative slope to it. Okay? Because this first term is always positive, and if the second term is positive, then the whole thing is positive, and if the second term is negative, then the whole thing is negative. So as long as y is less than positive 2, we're going to have negative slopes. As long as x isn't equal to 0, right? Because if x is equal to 0, then we're going to have 0 slopes. Okay, so there's a little caveat there also. Okay, so find the particular solution. Here is doing our differential equation stuff. dy dx equals x to the fourth times y minus 2. So we're going to divide both sides by y minus 2, okay, which moves y minus 2 to the left side, and we're going to multiply both sides by dx, which moves it to the right side. Okay, separation of variables. The y's go on the left, and the x's go on the right. So now let's take the antiderivative of both sides. Antiderive. So hopefully you recognize this as being a natural log antiderivative. Anytime we have a linear equation, especially a linear equation with a 1 as its coefficient, this is going to be a natural log type of a derivative. And on the right side, this becomes x to the 5th over 5 plus c, right? That's the antiderivative of x to the 4th. Now we have an initial condition, f of 0 equals 0. So that's the natural log of 0 minus 2 equals 0 to the 5th over 5 plus c. Well, c is the natural log of 2. Because in absolute value, 0 minus 2, negative 2, in absolute value is positive 2. Important to understand. So we're going to go back in here and replace this with c. So natural log, absolute value, y minus 2 equals x to the 5th over 5 plus the natural log of 2. Now let's solve this by exponentiating both sides, right? So e to the natural log, y minus 2 equals, now we're going to split this apart and change this into, we're going to do this one times e to the natural log of 2. Okay, this is our classic algebraic manipulation of our function. So the e to the natural log of 2, well, that's just 2. 2e to the x to the 5th over 5. Now when we add 2 to both sides, okay, you can put it in front or you can put it behind. So y equals, we could do 2 plus 2. That's usually how you're going to see it, is having 2 in front and having this crazy exponential thing after. 2 plus 2e to the x to the 5th over that. Okay, there you go. That's the last page. So slope field, this is usually how the slope fields are tested on an FRQ. You'll have some points, and then you'll have to do some type of a separation of variables to solve the differential equation with an initial condition. Alrighty, there we go. That is all. Hopefully this helps and your brain is ready for your differential equation test coming up soon, like tomorrow. Okay, bye.